basis, I'm going to hand over now to Arnaud Leyder from Radiant Media Player, and he's going to provide a little talk about what they're up to. So thank you very much, Arnaud. Over to you.
Yeah, thank you, Adam. Well, thank you for being there. I'm going to try and share my screen now. Can you see my screen now?
Yes.
We've got presenter view, if that makes a difference, but it's fine.
All right. So today we're going to talk about saving on energy in a web environment. So my name is Arnaud. I'm the founder of Radiant Media Player. We focus on building an HTML5 player, video player that goes everywhere. That is our focus. We are using our player to build mobile apps, mobile websites, Samsung TV apps, Xbox apps. Well, essentially anywhere and everywhere where web technology can go, we are making sure that our player fits that specific environment. So this presentation is here to tell you what we found out over the past 6 months about energy in a web environment. So first question is, can we effectively measure energy consumption in a browser or web view? As of now, mid-2022, the answer is both yes and no. We have an API that is an emerging API called the Battery Status API that is in JavaScript that can already tell us a few information about how and when energy is being used in a browser or web view. So it works for mobile and portable devices like laptop, essentially anything that has a removable battery. We can have access to the battery status API. We can see what are the change in battery status, like when the charge begins or when or ends, or when there is a level change. That level is expressed in %. So basically, when we have a video session, a player in the browser playing some content, we can measure when the battery is starting to discharge and see, you know, over a period of time, like half an hour, how many % of that battery has been used. And also give us information about charging time and the discharging time in seconds. There is, however, a drawback. It's not currently available in all browsers or web views. We have it in Chrome and Edge, but it's not available in Firefox or Safari. So the bottom line is we are starting to have something, but it's not complete enough. And we are hoping that this standard will further develop within the next months, next years, so we can have actual data. So we can get % level of the battery. But we cannot translate this to milliampere per hour, which is, you know, the data that we will need in order to really get a sense of how much energy is being consumed. But this is already a good start. With that in mind, that we can only get partial information, the question is, can we already optimize playback of video content in a browser with that specific API or with another one? And the answer is yes, we can, with Media Capabilities API. That is another API that is also in JavaScript that is supported in all modern browsers and web views. So that's something very nice because we can use it in Safari and Chrome, and everywhere there is a modern web engine, we can use it. We can also play with various input settings like the frame rate, the resolution, the bitrate, and it will tell us, it will give us information about what is, if the input configuration supported, yes or no. Do we have a smooth playback? And by that, we mean, do we have a consistent frame rate? Can we display to the viewer a proper a proper video experience, and is it efficient, power efficient, yes or no? So that notion of being power efficient is something that is, given to us by the browser. It's not something that we can actually measure. It's essentially the browser making a decision. The decision of how it makes, how it is determined, whether it's power efficient or not, is kind of a black box. It's Google, Microsoft on business to tell if it is power efficient or not. So that's the data we can get. Effectively, when we are streaming with HLS or Dash, we can have several codecs within a manifest, a streaming manifest. And based on codecs available, we can make an informed decision on which one to use based on what we want. And here we want, of course, low power consumption with the smoother playback, with smooth playback. Here we are going to review the media capabilities return values. Again, is it supported, yes or no? For you, I've already touched about HTML5 videos. You know that there is a can play type or is type supported method that is available in HTML5 video. The return value for media capabilities may vary from those more generic API available with the HTML5 video, because those methods do not onboard notion like frame rate or resolutions. So this is why its media capabilities API is so powerful, because we can really fine tune, we can really have a valid answer from the browser with very specific settings. It will tell us, of course, if it's smooth or not. And as I mentioned, this is really about draw frames. And is it power efficient? And the information we've been able to gather so far is that basically, do we have hardware or software decoding available? That is really the bottom line here. If it is hardware decoding, it will be flagged as power efficient. If it's software decoding, it will not be flagged as power efficient. There is emerging academic research on the subject. And one of the conclusions of that academic research is in the box down there. It's that hardware decoders outperform software decoders in power efficiency and decoding speed, but software decoders can remain efficient for low resolutions. So we talked a bit earlier about AV1 and the AOM aliens. So the idea that AV1 today is not having hardware decoding support in most devices. You have it like in latest television, latest TV, or latest, OTT boxes. You can have it, but in most devices, including mobile phone, like even the latest one from Samsung, they will not have hardware decoding of AV1, or if they have it, it's really emerging. Most people won't have it. But even if we have like software, a software option for AV1 decoding, we can still use it, but only for low resolution. Using software decoding for high resolution is really, punishing in terms of energy consumption. You can, I'm sure you have already experienced this, having, like an iPad or a tablet in your hand and playing content from YouTube, and all of a sudden, the device is starting to eat, and you are feeling uncomfortable because the device is overheating. So that's what software decoding can produce, and that of course is not a proper viewing experience. Going into details, I'm not going to give you a course about JavaScript coding. I just want you to look at this and see how we can what it looks like when you start coding with the media capabilities API. So you can input the content type. In that case, we're testing for VP8 in a WebM container. Then you can define the resolution, the bitrate, and the frame rate. You can test it directly as a file or with media source, which is the two most common types that we are using in HTML5 video, either a direct MP4 file or WebM file, or HLS and Dash, that would be with media source. And then we can also define an audio configuration there is something that is not well known, but that we know here on the player side, is that sometimes you have combination of video and audio codecs, and sometimes just the audio codec is not supported or is not efficient. So sometimes we can have variation about, you know, results and media capabilities, but just because of the audio codec. So that also is important. We are always talking, often talking about video, but audio also is an important part, and we need to onboard that notion as well. And then we get our call to media capabilities. We are querying the decoding info method, and we are ending with a result from a promise that is telling us whether it's supported, whether it's smooth, and whether it's power efficient. For our testing, for the testing that we have been conducting, we have been testing a 1080p resolution, at 5 megabits per second, and 30 frames per second. So that is what we are testing. And for audio, we are testing 2 channels. We can have more than 2 channels, like in, you know, Dolby Surround or other atmospheric audio environment. We can have 8 or even more channels. So that also can be tested with the media capabilities. And of course, the sample rate for audio, that is as well important. So this is the result. And we can already see that on basic environment like Chrome for Windows 11 or Safari for macOS 12, we are having unexpected result. So we have been testing with H.264, which is AVC, H.265, HEVC, VP8, VP9, and AV1. And we have been asking the brother to tell us what he was thinking about that specific, you know, combination of codecs at the configuration we've just seen before. So in Chrome 101, the best energy quality ratio is with VP9 and Opus Audio. As you can see, AV1 is not an option because it's not power efficient, and HEVC is not supported. And of course, since VP9 behaves better than H.264, then we are going for VP9. In Safari, AV1 is not available, at least not at the moment, not even in a software form. So we have AVC, HEVC, and VP8, VP9. And here we're going to go for HEVC because we feel that it can produce better results than VP9, at least on Apple devices. On mobile, we have been testing on Chrome 101 for Android 11 and Safari for iOS 15.4. And here again, we can see unexpected results. On Chrome for Android, we have AV1 hardware decoding on latest version of Android and latest devices on the market. So this is really the best combination that there is currently for Chrome on Android. AV1 and HEVC, HEV2 AAC audio. It's supported, it's smooth, and it's power efficient. On Safari, we have HEVC, we have VP9, and we have AVC. But as you can see with HEVC, so H.265, it is not smooth, which means that if we play a stream that is H.265 on a Safari for iOS device, even the latest one, iPhone 12, we tested on iPhone 12, we are not going to get a proper viewing experience for the viewer. We're going to get frames that are going to get dropped. We're going to get stuttering with the playback, and it's not going to be a smooth playback experience. So in that specific context, since AV1 is not available, we're going to go for VP9, because while both HEVC and VP9 are power efficient, it's not smooth. So that is why we go for VP9 and Opus Audio in that specific context. So this leaves us with a question. What do we do with this kind of information, and how can we build an energy efficient player with HTML5 video? So first, we're going to make decision based on media capabilities for MPEG- and HLS streaming. We're going to look first for smooth playback and power efficient. First, we're going to target hardware decoding that is available on the device, and then we're going to make sure that the playback is smooth. And as we have seen before, what we know, what we think we know is actually not straightforward. There are use cases that are even considered generic use case where you would say, all right, this is a straightforward code for HEVC, like on iOS for Safari, and then you end up with a different answer when it comes to what the programming is telling us. The programming is telling us that no, it's not HEVC, it's VP9, and we can see this on just two environments, which is in 4 environments, which is on mobile and desktop, Safari and Chrome. But as you can imagine, that would change also in environment like TVs and over-the-top boxes, on gaming consoles. The assumption that we are making that HEVC is always better is actually not correct, or that AV1 will always give us, a better viewing experience is actually not correct, because we actually don't know what the viewer is having in terms of media capabilities. Maybe they are using an older device. Maybe they are using, some specific power settings in the device that is changing, how the device behaves. We can imagine, for example, that in a low power setting in iPhone, maybe some codecs will be disabled, and this is not something we can know upfront. This is really about, the viewer device, how it's configured and how it's used, and we need to query each time we are playing back content. We cannot just make an assumption about this is the best combination of codecs for that specific device. We really need to have as much possible codecs combination available, which is, of course, is having a cost on the server side, because as we can see in our test, we have had 5 different codecs. So we need to adjust also on the client side based on what the server side can give us. So that is, beginning of a reflection of something we can think about on how the client and the server can work together to optimize further the energy consumption, because we know that some combination of codecs are going to be expensive also on the server side. We're not going to have them. But that, is something that the client can tell us, what is the best combination of codecs, what frequency are we seeing in combination of codecs being used. So that information from the client could eventually be sent to the server so that we can tell, all right, we need to encode for AV1 for Android, we need to encode for HEVC for that specific environment, and so on. And then, have encoding profiles specifically built for devices that we know are already optimized. So that's just something to think about. When we come to building the player, there are also other consideration that we can have, like in the ABR adaptive bitrate streaming logic, the algorithm, we can lean toward a less aggressive logic if we want to optimize energy. That means that the player will be less likely to go for higher bitrate. We're going to say to the player, we have a request from the viewer to consume less energy, and we want to use a less aggressive adaptive bitrate algorithm, so that we know that the bitrate that will be sent to the device will be less than in a normal configuration. So that's something that we have already built in our player. When we have a customer, a viewer that is requesting to have a low power environment, we are going to be less aggressive when it comes to upgrading the bitrate. We are going to say, all right, we're going to wait a little bit longer before switching up. We're going to remain on something much more linear when it comes to changing bitrate. Last but not least, we can cap rendition based on current player size. So that is something also that is built inside our player. it is essentially saying that in a window player, that is, for example, 640 pixel wide, we don't need to be sending like 4K video inside. Well, we can satisfy ourselves with a much lower resolution. A 360p resolution will be much more convenient for the viewer. We're not going to throw pixel and bitrate at a window player that we know won't be translating the qualities that UHD or even HD content is representing. So that's, really the three main options that are available today when you build an HTML5 player. Well, at least those are the options that we come up with. Making a decision based on media capabilities, have a less aggressive ABR logic, and cap transition based on current player size. And eventually, this gives us a mean to have a setting to give the viewer the option of using less energy. And I think that this is, very important here. Our conclusion is really about giving the final viewer the final decision about whether or not he or she wants to use less energy, because we eventually don't know what is the network configuration. We don't know, what are the current profile of energy settings that the device is having. So we really want to give an option to the viewer, but eventually that option can be disabled if the viewer feels that consuming more energy will give them or a significant increase in viewing experience. So like I mentioned, this is all very emerging in a web environment. We still need to have more data. We still need to have more feedback from customers. We still need to have more benchmark. And this is what we can do as next steps. Start to have benchmark with the battery status API. It will not give us milliamp per hour data, but it will give us percent level. So we can have more information to make decision. We can have a better picture of what kind of device consumes what kind of energy. And eventually we're hoping that a web standard will come that will tell us what are the watts being consumed. That really is the end game on the client side. Today we don't have that information. There is simply no way to get that specific information. Even with native application, we have been looking at that as well. There is no knowing in terms of watts, in terms of milliampere per hour, how much energy we are reading. So we are hoping something will come up with that. But in the meantime, as I mentioned, there is also a lot of things that we can do. So that is it for me. If you guys have any questions, I'll be happy to answer them.
Awesome.
Thank you so much, Arnaud. That was a wonderful presentation. I found that really interesting and informative. Like you say, I'm going to hand over to anyone who has any questions. I know a question came in from FX, and I'm going to ask Dom if he will raise it because it's a little bit beyond my technical ability.
So I had a read through it, and I think the key issue he's raising is, making a decision in the player drives different infrastructure changes deeper down in the network, and understanding the delta through the network kind of needs to be accounted for before any decisions made. That's he's posted it in the chat room before he left. So unless I'm misunderstanding his question, I think he's raising the issue that doing something at the player, we have to also consider the end-to-end effect. Maybe I can sort of, hoping I've kind of understood what FX is driving out there. Maybe I can frame the question. Arnaud, do you think that the data set that you're now sort of starting to make decisions on in the player is something that you could also provide feedback down the value chain from? So rather than making every single combination of codecs and video and audio codecs available for every different browser, if you find that your entire audience is only watching on Chrome 101, is there a way you could signal back down the supply chain to say, you don't need anything else, we're just going to take this one codec because it's super power efficient and turn everything off? You know, is there a possibility? We've got encoding operators, we've got caching operators in the room even today. I wonder whether this is a data set that could be acted on more broadly than just in the player.
Yes, so as I was mentioning, this is all very early and emerging, but yes, you know, that's essentially the idea. I think one of the end game is to give, you know, is to query the device before we start even requesting data from the server, and based on that query, which is, you know, considering the notion of power, based on that, you know, input setting, we can, you know, already tell the server we need to have, you know, like, I don't know, VP9, for example. That's, you know, for that device in that current configuration, this is the best things to have. But I think that eventually the part that is important is to define encoding profile, because we know that H.266 is coming, we know that AV2 is coming, and we also know that H.264 is going to be here for at least another decade, right? So let's say in 5 years from now, you're going to have AV1, AV2, you're going to have H.265, H.266, and H.264. And basically the question is, I am a content owner, I want to make that content available to the streaming world. What are the profiles I need to encode to in order to reach, you know, the vast majority of devices? And it shouldn't be, the answer shouldn't be encode all codecs, right? It shouldn't be you know, on the server just, you know, encode with all codecs and then, you know, let the player make the decision. We should be able to tell from the client to the server, all right, this is, you know, the current audience that we are aiming. And I'm talking about that because we have customers that are not using our player for the web, I mean, classic web. They are using it, for example, to develop TV application. And for TV application, like on Samsung or LG TV, we know that they have, you know, super advanced hardware decoding capabilities. You know, they already support decoding of AV1. So that is essentially, we don't need more than AV1 and H.264, because we need AV1 for the latest one, and then, you know, H.264 for the one that are models from 2015. So that is basically, you know, what I think we should be leaning toward to and aiming, you know, having this kind of data sent from the device to the server. But that is in analytics, you know, analytics perspective, you know, like something we could maybe even do with human, not robots, not in the context of streaming. You know, send that data.
I was wondering whether we should be getting a data feed from you guys, and you know, maybe then we could derive across the experiment. When the audience who were watching on Chrome with this combination came online, we saw a delta in energy. Presumably we can't, if we can't get the actual wattage to derive milliamps or whatever it is, we can only ever talk in deltas of percentages within this environment rather than talking absolute numbers. If I understood correctly.
So yes, so that's essentially the idea, is we are going to reduce consumption of the device, but we are going to do that with the server, not, you know, blindly with the device. And then, you know, we can have a less encoding done on the server, because we know that there is no need for one specific codec, because we don't need to support that codec for that specific environment. So yes, I think we could come up with that, you know, in the next year, significantly reduce the power usage on the server, because the client is telling we don't need those codecs anymore, or those codecs are not power efficient, and we don't need to use them.
It's like doing the DIMPAC report in real time. Anyone else got any questions?
Just to mention, so Mark from Cortex speaking, just to mention that what you described, Arnaud, is very similar to what we've been doing with another player vendor, which is not in this group, unfortunately, trying to adapt, you know, the rendition ladder in real time based on various conditions that included not only, you know, the battery of the devices, but also the CDN conditions and the greenness, I would say, of the profiles. So that's very interesting, because on our side, you know, we have this specificity that we provision, you know, the infrastructure fully on the fly based on what we encode and what we package. So it would make sense maybe to try to work together on investigating what the impacts would be if we try to get data from you and just encode what it takes to reduce the footprint. I think it would be interesting. So maybe Arnaud, we can think back on that and try to work together on that.
Yeah. So as I mentioned, we intend to run benchmark within the next, I would say, 6 months on, and having this profile available for telling Android that specific version on Chrome. We have to have those codecs, and only those are enough, so that we can have reduce power impact. So yes, definitely, yes, we can talk about that.
Perfect.
Tim's come on cam. Go on, Tim.
Yeah, no, I posted 2 links there, and Arnaud, you may find it interesting. Well, it's primarily focused toward the M1 chip, and it shows very well that hardware decoding in Chrome, it takes 2x power consumption for Safari hardware decoding. It's interesting that this study also deals with some of the newer A chips that go into iPads and iOS devices. The big trick, and this is something we end up having to do, is put devices in safe mode or take it back to just the basic operating system, so that we don't have other things that are changing the power consumption metrics. There's a power metrics piece inside at least Mac OS and iOS that lets you see really nice details on where it's implementing hardware decoding, where it's implementing software decoding, and what the power consumption was for those given decisions.
Mm-hmm. I didn't see that studies. I went over the web and I look at a couple of academic studies that are starting to talk about this. Basically, I will review this, but I can see that there's people are getting milliwatts, and that's basically the information that we will need at the end. So that's a good thing, something that I can look for. Thank you for the link. I will look into it. But yes, basically the idea is that hardware decoding is top of the line, and we really need to aim for those. And also I think that there is a lot of settings that can affect the energy settings. Like I was thinking about DRM, for example. Like if you have DRM on a content, it's going to consume more energy? Yes, but is there a specific combination of codecs where it will consume less energy with that specific DRM? And so on. So this is very interesting material. I will have a look at it. As I mentioned, I went through an academic study that is available online, but it's basically the conclusion that I said is that hardware decoding is always preferable, but for new emerging standard like AV1, AV2, or H.266, software decoding can be a valid option at low bitrate and low resolution. So even if you don't have our decodings, then you can still use the codecs at low resolution, which is what we want in mobile devices, to make sure that we have a less bitrate sense, and H.266 will be definitely outshine the other. That's the idea.
Yeah, DRM is covered in there, so take a look at that definitely.
Yeah, definitely. Thank you.
Cool. Well, listen, anyone else got any other questions they want to put to Arnaud? I think we're sort of coming up for about 1:30, which is perfect. Okay, well, look, I'm gonna suggest that we wind Green Stream number 2 up. But Arnaud, can I just say thank you? That was an absolutely excellent presentation, really engaging, really on topic, and just broadly enlightening. So deeply appreciate that, and we'll be chopping this up and turning it into a podcast to push out on the Green Streaming site in the next day or two. Adam, let's hand back to you just to close the monthly members meeting.